Is Wednesday the second?
Wednesday is the 2nd.
Okay.
You turn this in here?
You don't need to turn anything in today.
Not even the channel thing?
No.
What if we didn't finish it last class?
Well, then you got lucky I'm not taking it today.
Oh, okay.
I didn't take it up for anybody yet.
Oh, okay.
You guys have your test next class, so I don't generally take stuff the day before the. I don't usually take stuff on the test review day, because if I happen to not grade it and get it back to you, you don't have it to study with. So I will take it up from you next time. Or I'll try to open it up in Google Classroom here in a bit, if you prefer that.
How do you feel about this week's test?
Not too great right now.
Tried to finish it last night?
We are mostly going to be looking at handout 28 today, so please get that out.
So we can charge my calculator in here.
Huh?
So we can
Yeah.
charge my calculator.
Just remember to take it back. Okay, I guess our intercom's messed up again this morning. All right, so next class, we are finally to our second assessment, our Unit 2 assessment. So I'd like to start off by reminding you about the late work policy. So anything you did after our first limits quiz till now, any of that stuff you never turned in and have a 0 for, as long as you go back and finish it 100%, you can get half of those points back. And if there was anything you turned in incomplete, but you went back and finished it, as long as you turned it in before we start the test on Tuesday of next week, you can get half of those points back. But as soon as we start that test, I won't take any more homework classwork points from Unit 2. So if that sounds like you, then you need to add that to your homework list. Additionally, if you do have any late work to turn in, feel free to throw that in Google Classroom, or you can give me the hard copy. The only one that's a little tricky is the Khan Academies from a couple classes ago. You have to email me and tell me you did those, because I don't just randomly go and check those scores every single day and compare them. So make sure you're aware of that stuff. So we did finally, I should have said this a couple classes ago and then I just got wrapped up in the other stuff we were doing, but everybody did finish the Unit 1 quiz. So remember, you are welcome to come and see it during advisory. In fact, you're encouraged to. Even if you checked your grade online and you made 100 on it, you may remember I gave you 2 free points. There was 22 points you could earn on that limits quiz, and I only graded it out of 20. So even if it says you made 100, you might have actually missed 2 questions. So anytime you guys want to sign up for advisory, it could be this week, well, not this week I guess, but it could be next week, or it could be in March. Doesn't matter to me, but I would recommend you come and see that. The other thing I can share with you, I don't know that it means much, but sometimes you guys seem to care about this stuff, but just class average on the first quiz. And then before and after, I have to do this stuff anyway for one of my evaluators. So before the curve and after the curve, you guys are the second period. So all pretty consistent overall.
What was the curve?
There was 22 points you could earn,
Oh, okay, so
and I only graded out of 20. Yeah. So some people got no curve. People who got all 22 points or 21 points already had 100, so there was no curve for them. But anybody who missed more than 2 points got a point or 2 added. So anyway, I would say just from the last couple years, Unit 2 tends to be roughly the same average, maybe a tiny bit lower. And even though it may not make you feel better right now, when you guys go back and look at Unit 2, like at the end of this semester and before the AP exam, students usually spend less than like 30 seconds, because at that point they think, oh, this stuff was super easy, but part of that's because they keep using it. Product rule, quotient rule, chain rule, power rule. We're learning how to do those things in Unit 2, but it's really for us to know how to do those, but then also because in the next unit we're doing implicit differentiation and related rates, and you got to do product rule and quotient rule and power rule and chain rule within those topics. And then we'll do first derivative test and second derivative test, and sometimes to take the derivative you've got to do product rule and quotient rule and chain rule and power rule. So that's why students always think this unit is pretty easy by the end of the semester, but of course for your grade you want to be as ready and as prepared as possible. What's that?
Oh, this is just
Okay, you don't have to turn anything in today. Yeah, I'm not asking for your circuit from last class only because your test is next time, and there's always a chance that if I take it up from you today, I don't, just depending on how many questions y'all ask and how much help you want, I may not get them graded and back to you, and I don't want to do that. I don't want to have those resources away from you. So I will ask for that chain rule circuit along with your test review and late work and all that kind of stuff at the start of next class before we start the quiz. Okay, so I did ask that you do some of this already, so for two reasons. One is so that you can finish this in class, identify the questions and topics you actually need a little bit more help on, and then your homework can be strictly on studying, but also by asking you to look at some of this ahead of time. You probably have found some things that you know that you're not quite up to speed on. So I don't know if you realize the format of this, but the test review is mostly just trying to remind you what topics there were and help push you into the right direction as far as what to study. So like looking at page 1, the first topic is about the standard and alternate definitions. It reminds you of the two forms that you have to memorize. And then it gives you a couple practice questions, 3, 4, 5. It gives you a sampling of, okay, I've memorized those. Let me try it on a couple questions. If those 3 questions seem easy and I'm getting the answers right with what the website says, then I'm probably okay with that skill. And then once you think that you're good with that skill and you don't need to study it, you can check it off. But if after you look these up in your notes, fill it in on your test review, you try these 3 questions, you still feel shaky, you realize that's not enough practice, I have already linked some bit.ly links per topic where you could get some extra practice. So if you realize this is the same Khan Academy I think that you guys did a couple classes ago, but if you need to practice more before the test, then you need to practice more before the test. So of course that's optional, but I try to make that as convenient as possible. And then format follows pretty much the same way. Reminds you of power rule, make sure you know what the power rule is, practice a question to make sure you can do it right. A couple places you could practice the power rule if you need more practice. Then product rule, what is it? Practice 2 questions. Quotient rule, what is it? Practice 2 questions. If you need extra practice, there's convenient links. Chain rule, what is it? 2 practice questions. Speed versus velocity, these velocity graphs we looked at a while back. Equation of tangent lines, practice question. Derivative trig functions, 1 practice question. So again, mostly it's just trying to remind you of the topics that would be fair game / give you a couple practice questions to help you see if you know it as well as you think you do. Okay, so I realize you don't have every question that you're going to need help with ready to go because I didn't insist you had this finished. But within doing the first half that I did ask you to do, which questions did you guys try and realize you need some extra help on? In there, you need to take your headphones out though.
24.
Huh?
Was it the 24th?
Yeah, 24. That sounds right. Any questions y'all found yet that would help for me to go back over? Yeah.
Page 39, I don't know if that's like the first time.
Oh, it's, well, when I say first half, I just meant like whatever questions you chose to do. It didn't actually have to be the literal first half. I just wanted you to have a chunk of it done. So 39, yeah, 39 is probably one of the harder questions on this review. So that is a good one to ask.
Yeah, what does that derivative mean?
Okay, well, what does dy over dx mean? What is this asking you to do?
Get the derivative.
Okay, the derivative of y with respect to x, although everything we're doing right now is with respect to x. So if they put a 2 here and a 2 here, what would you guess that means? Second derivative, right. This means second derivative. So there's 2 ways to say that. You can either say d squared y over dx squared. That's asking you to find his second derivative. Another way is if you had y y prime would be the first derivative, and y double prime would mean the second derivative. So there's two ways to ask for a second derivative.
So it's the same at 36 and 37 are basically the same.
36 and 37, yes. Two different notations for the same thing. Okay, so when you start off question 39, right now all we have is the function. So we have to find the first derivative first, and then we can worry about the second derivative. So to take the derivative of this would be power rule. Bring the 3 down and lower the power by 1. Every time for the rest of your life, now that you take the chain rule, or I'm sorry, you take a derivative, you need to ask yourself, what is the derivative of the inside of this? If it's 1, you don't have to write that. But if it's anything else, like this one, 6x, you need to keep up with that. So if I try to clean this up a little bit, I've got 3 times 6, which would be 18. I've got an x, and I've got a 3x squared minus 1 squared. But that's only first derivative. Notice that answer is right here, though. So again, I think this was an actual AP question years and years ago. But they're expecting some people to pick this by not knowing that this is asking for second derivative. Okay, so now down here, I'll start to do the second derivative. Did you find what you needed? No? Okay. I'll do the second derivative. So I've got 18 times, so constant multiple rule, we can just do 18 times whatever the rest of it is. I'll worry about the 18 later. The rest of this, you have to do product rule. You've got x times this stuff. Or, if you would rather, you could FOIL this out and distribute the x, and you could do power rule then if you wanted to, I guess. But I'm not saying that's easier, it's just different. So, derivative of x times 3x squared minus 1 squared left alone, plus leave x alone, take the derivative of 3x squared minus 1 squared. So, this is going to be power rule. Bring the power down, lower the power by 1, and since I'm taking the derivative of something that has an inside, I need to consider chain rule times a 6x. So the second derivative is 18 times, if I try to rewrite this, I've got a 3x squared minus 1 squared, and over here 2 times 6, x times x, and also has a 3x squared minus 1.
Where'd you get the thing from on the right side of the, that's first step, x times 2 times 3x squared minus 1 times.
That's part of the product rule. I'm doing the product rule. First derivative, something times something, you've got to take product rule. Derivative of the first, second part left alone, plus the first part left alone times the derivative of the second part. Okay, so what comes next? This is one of the easiest algebra things you've ever learned. It took you about 5 minutes to learn this algebra skill. But it's not so easy to see in calculus. You need to realize this term and this term have something in common. It has a GCF of a 3x squared minus 1. So you can actually factor that out. And you could combine like terms, which gives you choice A. So again, that underlined in blue, I don't know why that's always difficult, but if they have the same term, you can factor it out, even if it's a binomial. It doesn't just have to be a single term. So again, that's one of the harder questions, but 30-second review of it. I took the first derivative, power rule, chain rule. I cleaned it up as much as I could. To take the second derivative of this, I had to do product rule because I wanted the derivative of something times something. So I did the product rule. Within the product rule, there was one time I needed to do chain rule, the 6x. I multiplied this stuff, I multiplied this stuff, realized these two had a GCF, pulled it out front, and then I combined the 3x squared with the 12x squared to get 15x squared. You okay with that? Alright, again, I suspected several people probably should have asked about this one, so does anybody have anything else about 39? Okay, other questions you have ready? Okay, then let me give you some time to pick up wherever you left off.
So we need to know not just how the product quotient rule works and how to do it, but also what it looks like in the form of an equation.
Well, to me, that's one and the same. If you know the equation or the formula, you should be able to apply it, and if you can apply it, then you really know the formula. So, to me, it's the same thing.
Meaning like stuff like number 6, like you write it in directly.
Yeah, I mean, I would not, I guess you wouldn't have a test question that looks just like this, but if you can do the power rule here, you could do the power rule here. You could bring the exponent down and lower the x power by 1. I mean, that's all you do with the power rule. It's just a generic number n instead of something specific. Problem is, if I put a specific number there, then it looks like maybe it only works for that specific number. If we leave it generic n, it's a good way to show that it works for any number. Bless you. And I'm sure it probably seems like there's a ton of stuff to memorize for this class. There's really not that much. It's just that the majority of it kind of hits you guys here in Unit 2. Memorizing the trig derivatives, memorizing
derivatives like e to the x and natural log of x and stuff like that. If you consider quotient rule and product rule formulas, I guess those are things to memorize. Standard and alternate form of a derivative are kind of formulas to memorize, but there's really not that much to memorize for this class. It's just a lot here at first.
5, I don't see a difference between B and D.
Question 5. That's a good question. Yeah, sorry, I have a typo on here. I retyped this year because these were too hard to read. Question 5, B and D look the same. Choice D is supposed to be G prime at 1. Thank you for telling me. Okay, so it's been almost 10 minutes, so is there any other questions you have found? Yeah.
So for 26,
Mm-hmm.
I don't really understand how you got 2 as the second.
26.
Because c gets rid of pi is -1.
Why are you doing pi?
That's a great question.
Should be pi over 4. Okay.
Sorry, I already did that.
No, you're fine. Let me know if you still need help with it. Okay, anybody else have a couple questions ready to go? Again, I want to help you as much as I can today, but can't help you with things you don't tell me. Okay, I'll give you a little bit more work time then. Alright, it's already been another 10 minutes, so I'll offer again. Any of these I can help with?
45.
45?
45.
25?
Yes.
Okay, so for 25, tangent lines are like a representation of slope at that instant, which in calculus we don't usually say slope, we usually say derivative. And horizontal lines always have a slope of 0. So anytime you're asked to find the equation of a horizontal tangent line, you need to find the derivative and then set it equal to 0 and solve. Because that's when it's going to have a slope of 0, which is what a horizontal line has. So on question 26, you'll have to find the derivative at that point. Actually, I'm sorry, you can find the derivative, set it equal to 0, and solve. And that will tell you the x values where the slope is horizontal. Okay, what else? Okay, go ahead, keep going then. Got about 50 minutes here, but again, this is the last time I see you guys before your test, so. Okay.
So I have to take the derivative and plug
Mm-hmm. You gotta plug in the point and plug in the derivative.
it. Yep. So the derivative. She squared.
At pi over 4.
Yep.
Mhm.
Do I?
So that's,
I should do
yeah, you gotta go to the unit circle, think about pi over 4.
that. Yep.
Sine is square root of 2 over 2, so cosecant would be the reciprocal of that,
Yep.
which is just square root of 2. But then, so then you know the slope, and then you know the point, and you could put those into point slope, and then for whatever reason on this question, they just rearranged it some, so. Okay, anything else you wanna talk about? Here, C, put this up alone, U up alone, take care of this, you're close. The derivative of sine something is cosine something, but you need to multiply by the derivative of the inside now, you gotta go change the one now.
This one.
Hold on. I don't know, it looks good to me. Was it just something I answered online? Yeah, well, I mean, that's the hardest part, really, is for everybody. Yeah, but you could, the derivative of natural log of something is 1 over to something, which is the same as opening it. You never take the derivative of the inside of the chain rule, with unfortunately quotient rule. All that looks right. I think it's fine, but I double check it. I don't see anything wrong.
I don't really understand how they're going to rewrite this as these two. Is that just a
Okay, so I split the fraction, but this over x squared and this over 1. When you put x over x squared, it reduces to 1 over x. Oh, I know what I did here. I mean, there's lots of ways you could do it. You could do the natural log of some stuff is 1 over some stuff.
I
And then you
tried,
can put that.
just.
And then that's what she was asking me, chain rule. You'd have to take the derivative of this, which is a quotient rule.
So I was doing 1 over some stuff, and then multiplied by the inside times the quotient rule. And I just canceled it.
Okay. Well, the thing that I did here, which apparently I thought was easier, of course, it's not multiple choice, so I don't know how I should go about it. But I split this up. Natural log of something divided by something, you can expand. Remember expanding and condensing?
I didn't know that was
If you have, well, if you were going to condense, 2 logs of the same type separated by subtraction could condense into division. So expanding, you can split them apart that way. That's a lot.
So that's just a property.
Yeah, well, you don't need to know it often, but it does come up a couple times throughout the year.
Okay.
If you do know that property, that's a lot easier, because then this is
Yeah.
one that's short to memorize. This is just the same thing, except you need to know the chain rule, so it's a lot easier.
Okay.
But,
so then
yeah.
we can just be split.
You can also just do the natural log of this, the derivative of this whole thing, which flips the fraction over, chain rule, quotient rule, yada, 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 which is, your answer might look a lot different, but it might be the same.
Yeah. Would this be like correct technically? Because that, I multiplied that out, and it just came out to,
Well, this, I don't know how to read this part right here.
is it, I don't know, that was a complex fraction.
It's 1 over x.
Is that just the inverse?
I know, but this, I see 1 over x. And
Over
then,
x.
okay, well, I don't see any fraction bar there.
Okay,
That's
sorry.
why. So sure, but if you're taking this fraction, dividing by this, that's the same thing as multiplying by the reciprocal.
Mhm.
So really all that happens is black fractional flips over. Doing 1 over something is the same as reciprocal, so
Okay.
so if this went up, I'm good with that. Then
Yeah,
you
because
have
I
to
did
do,
end up with the reciprocal. And then I multiplied it by that. That was,
and why do you multiply by that?
because it's the, because I used to derive everything sometimes, the inside derivative.
That's this. That's the derivative of the outside with the inside derivative.
Oh,
Now you gotta take the derivative of this for chain rule, which is quotient rule.
so I didn't, okay, that makes sense. Thank you.
Okay. It's been a while since I offered to help out on the board, so can I do a few up here to help you out?
18.
Number 18. One thing about number 18 is, and this is kind of my fault, but really to answer question 18, you would have to use a calculator at least at the end of this question, because plugging in 1.5 is not going to give you a nice whole number here. But the first part we can certainly do without a calculator. If you have velocity and you want to know something about acceleration, you have to know that the derivative of velocity is what gives you acceleration. So you can take the derivative of this now. It's something times something, so you have to use product rule. So let's do the derivative of t times sine of t squared left alone plus, leave t alone, times the sine of t squared. And the derivative of sine something is cosine something. And since the something doesn't have a derivative of 1, we need to multiply by his derivative. That is chain rule. So technically, you could make the acceleration function look a little bit nicer here. But this is the acceleration function. And so if you want to know the acceleration at time 1.5, you just need to plug in 1.5 into this. And this is where you would have to use a calculator anyway. The sine of 1.5 squared plus 2 times 1.5 times the cosine of 1.5 squared tells us the acceleration at this time is about,
It says negative 2.049 on this.
okay, I'm going to type it in though on the calculator.
Would not be 2t squared cosine because of the before cosine.
Sorry, where?
On like the upper equation, it's 1 times sine t squared plus t cosine of t squared times 2t, so it would be 2t squared.
Oh, you're right. T times t should have been t squared. Yeah. So let me freeze my screen for a second so I can type this in. And even if you're feeling okay about this question, stick with me here a second, because there's still one more thing I want to make sure you get out of this. 2 times t squared cosine of t squared. Okay, so I'm about to hit enter on this. I found the acceleration function by taking the derivative of the velocity function. They want to know the acceleration at 1.5, so I'm plugging in 1.5 for t. Now again, the only reason you have to have a calculator for this question is you don't know what the cosine of 1.5 squared is. If these values were not 1.5, but maybe something from the unit circle, then that would be fair game. So hit enter, and Landon, you told us the answer a second ago.
Negative 2.049.
Right, which is nowhere near what I have. So look at what I typed in, what answer I got, and that's not the correct answer. So what did I not do here?
It needs to be in radian, right?
Exactly. Everything we do in calculus is supposed to be in radians. If your calculator is in degrees, it thinks you want the sine of 1.5 squared degrees. You have to be in radian mode. The good news is you don't have to switch back and forth like pre-calculus. Okay, and then you said negative 2.049?
Yes.
Okay, so notice, exact same thing. The top answer doesn't look wrong. There's nothing obviously wrong about it, but it was wrong. Your calculator has to be in radian mode anytime you're doing a trig function. Any sine, cosine, tangent, anything like that, if your calculator's not in radian mode, it will be wrong. But there's one more thing I want you to get out of this. If this question needed a calculator at the end of the question, that means it would have to be on the calculator part of the test, which there's a lot easier way to do this whole question if you have a calculator. What would be easier than taking the derivative of velocity to get acceleration, doing the product rule, doing the quotient rule, plugging in 1.5? What would be smarter than all of that? Okay, that's what worries me. If it's a calculator question, I think we did this exact question in your notes, by the way. Your calculator can do derivatives at a point. Alpha window, tell me the derivative in terms of x sine x squared. Obviously you can put t's there instead of x's, but I wanted to know at 1.5. Same answer, much quicker. You were allowed you would need a calculator either way, so why not just let your calculator do the derivative? Then you're not risking messing up the product rule, the chain rule, or typing it in your calculator funny. So, but for this, your calculator also has to be in radian mode. So, anytime you have a calculator, if you need a derivative at a point, do yourself a favor and take the easiest possible path, which is just let your calculator do it. Okay, a couple more. We're down to about 30 minutes of class now. Yeah, Rich? 39. We already did 39. We did that one at the start of class. But it is up on the website as a video, so you can still get it from that. Okay, I'll check back in with you one more time here before we run out of time, so let's keep going. from velocity to acceleration? Okay, and derivative means the same thing as this. Okay, so the slopes of these lines is these acceleration. So if during this time it's got a slope, during this time it's got a slope, and then I'm sorry, acceleration. No, it's 60 over, 60 over 10.
I couldn't understand.
Because what about this x? Isn't there 18 x there? Okay, then we're pretending like the x isn't there, working this by bringing the power down, lowering the power by 1, and chain rule, and then we're squeezing the x back. Doesn't work that way. Is that what yeah, it's something in terms of x times something in terms of x. You have to do the product. Or you could boil this out and then distribute your x, and you have like 3 or 4 terms, and then you can do power rule a couple times to get the derivative. But if you do it that way, it's not going to work anyway. So. Anything I can help with? Yeah, you should be thinking about slopes, but since there's, I need to add values there so you can actually calculate it. So it's good that you realize that something's off. Yeah.
So, do we do this for every project in our study?
Okay, so what's the relation, how do you go from velocity to acceleration?
We did the derivative.
Okay, and what's another term for derivative? Derivative is basically the same thing as slope. So the derivative of velocity gives you acceleration. So the slope of the velocity function gives you acceleration. So you need to be thinking rise over run, got the same acceleration during this time, same acceleration during this time, same acceleration during this time, etc.
So we just plug in, like we just use this function and put in like 10 seconds.
This has to do with question 8, and this has nothing to do with it.
So you have to get the slope and then
So you're gonna count right over run, going up 60, right 10. So the slope during this time is 6. So that means the acceleration during this time is 6 per second squared. The slope during this time is 0. So the acceleration is 0. Slope means derivative, derivative velocity is how you know something about acceleration. How's it going? You got anything help with? Anything for it?
It's right here.
That's how it does that.
Why would you be uploaded to your website? I know that
I'm not posting the resolutions.
Okay.
I think all of them, but like the last 4, some have videos. So once you get it down to the last 4, your work, you should be able to kind of figure out which one it's supposed to be, which process elimination. So
How do we get acceleration without that one?
that's a good point. You can answer those.
Okay.
But that's good that you realize that you would need to calculate slope, and if you don't know how much it's going up, then you can't do that. So that's my fault. Okay, you started off right. So if you know this derivative's 1 over that, this derivative's going to start off as 1 over that. But now you need to multiply by the derivative of the inside for chain rule.
Oh.
So times 2x plus 7
Yeah.
or whatever.
Yeah. It's hard to make yourself think of that every single time.
Yeah. Okay, we're just under about 20 minutes, so offer one last time to work out some of these questions on the board. Okay, while you make sure that you don't have anything, again, this should be your go-to as far as knowing what you're responsible for on the test / what you might need to review in your binder and maybe get more practice on. Pretty much, well, I'd say if you're comfortable with the test review, you should think that the test is easy in comparison. but everything on the test review should show up on the test. So I don't know if I would put one that uses the standard definition and the alternate definition, but there's probably going to be at least one of those. There's probably a ton of questions that will need the chain rule, or I'm sorry, power rule. There's going to be at least one question where you've got to do the product rule. You know there's going to be at least one question where you've got to do quotient rule. There'll probably be at least a few questions that you need to do chain rule. There's a couple of these velocity graphs on your test review, so you should expect one of those on there. Some of these are just extra practice. The 6 trig derivatives. I don't know if all 6 of those will show up on the test, but 3 or 4 of them probably will. So to make sure that you can do them all, you need to make sure you have all 6 of those memorized. So again, I think you treat this test review kind of as a practice test, then you should be in pretty good shape. As always, I do print off a few extra of these, so if you know that you would like to redo some of this or all of it a second time, feel free to help yourself to another copy. I'll leave the extra copies in the bin over there. You just have to go to the folder that has the number that matches this assignment, which for us is number 28. And of course, make sure you bring your binder so that you'll have the things that you need to turn in. I will also open them up in Google Classroom during advisory today, though, if you want to turn them in early. Okay, last chance. Anything else on the board, y'all? Ryan?
You do
45?
55.
55. Okay, so the second I glance at 55, I realize there's no algebraic way to make this look simpler. And then I notice that I've got something in terms of x divided by something in terms of x. So if I want to differentiate or to take the derivative, I know I'm going to have to use the quotient rule. So you better either memorize the quotient rule and then write it on top of your test when you get started, or make sure that you have the pattern down. If you misremember that, that could be 3 questions. 3 questions might be quotient rule in the test, so it's too important. So take the derivative of the numerator times the denominator left alone, and then it's a minus, and then do it in the other order. Leave the numerator alone times the derivative of the denominator all over the denominator squared. So that's what the quotient rule tells me to do. And then of course, if it's a multiple choice question and none of the answers look like what I have, you're going to have to simplify it some. So you could distribute this 3. You could multiply these 2. You could combine like terms. 3x squared minus 6x squared is going to give you negative 3x squareds, and there's a plus 3 over this. Now for me, I can see that that's going to be D, but you might need to play with it a little bit more. Looks like they factored out a 3, and then for whatever reason move this term first and move this term second. And down here, again, for whatever reason, they swapped the 1 and the x squared around, but that doesn't matter. So that's why D is the answer. That one was just quotient rule. Now notice when I took the derivative of 3x, I didn't need chain rule because the inside is just an x. It's 3 times x. The derivative of x is 1, so I didn't have to do chain rule there. Likewise, when I did the derivative of x squared plus 1, x squared doesn't really have an inside other than x, and the derivative of x is 1. So there was no chain rule to question 55, just straight up quotient rule. Okay, was there something more specific there? Is that enough?
Yeah, I didn't do that last part. Like I didn't recognize that D looks like what I got.
Yeah, and that's why Like, I know some of the simplifying we've been doing in the long book assignment and some of the circuit questions are borderline nightmare, but if you guys don't practice forcing yourself to think of complex fractions and common denominator, then occasionally you might miss a question just because you can't think of any way to try to rewrite it. So okay, did you have another one, Ryan, or was that it? Anybody else? Yeah. 43. Okay, so kind of the same as the last question. I see I can't rearrange this with algebra to make my life easier, and I've got something in terms of x divided by something in terms of x. So once again, this is going to have to be the quotient rule. So I can't help you memorize that. Just takes practice. But quotient rule says take derivative of the numerator, that's one we memorize, times the denominator left alone, minus the derivative of the denominator times the numerator left alone, and make sure you don't forget to put it over the denominator squared. Now, this isn't multiple choice, so I guess technically if this was a question on your test, I guess you could circle it and move on, but if it was multiple choice, I'm sure they're going to simplify this. X squared divided by x could just become an x. I don't know, none of this stuff simplifies. I guess both of these have an x in there, so I could divide everything by x or factor it out and cancel it out, which is the same thing. So I would probably make it look like this. If I was making a multiple choice question. Is that enough? Okay, so again, as I was saying, if you use this test review and make sure that you really dig in and just tell yourself the test is going to be just like this, then you should not feel like you have any surprises or any real curveballs. But we do have about 10 minutes here, so go ahead and keep going where you're at if you'd like to. Again, I will ask for some recent assignments. This test review will probably be a 20-point assignment just because I realize it's longer. And it was basically a full class period of work plus a homework assignment. Remind you about late incomplete work. If that applies to you, make sure you add that to your to-do list. If it's the Khan Academy, make sure you email me when you're done, because again, Khan Academy doesn't tell me when you guys turn in stuff late. The only way I would know is if every day I checked this person's grade to Khan Academy, and then the next person's grade to Khan Academy, and the next person's grade to Khan Academy, and see if anything ever changed. So you need to email me and tell me that you're finished with those if you were doing late incomplete work on it. I will surely take up the circuit next class from last time. I will certainly take up the test review, and I think there might be like one other assignment. But as I said, I'll open those up in Google Classroom so you can turn them in early if you want. Otherwise, make sure you bring them with you for our test on Tuesday. Okay, and then if you'd like the puzzle to play with, I don't know that I can give you any good hints on this one, but there. Well, actually, first, y'all did this one already? Okay. All right, then that's the one you're on.
if we turn something late to Google Classroom, should we email you too?
No, because if it's turned into Google Classroom late, Google Classroom emails me.
Okay.
So,
Do you want to lay work on the day of the test or today or just anytime?
I don't want you to give me any hard copies today because I can't promise I can grade them and get them back to you to study. But
Okay.
if it's Google Classroom, you can turn them in now.
Did you put like 22 and all that on the Classroom?
I'm about to.
Okay.
Yeah. But no, I have no preference whether y'all give me hard copies or Google Classroom. It's just that if you lose your binder, you lose those handouts, you forget your binder, it could impact your grade, whereas Google Classroom, turning it in early negates all that.
Do I
So,
not get full credit on this? It's something that has a 0 on the grade book.
Well, you didn't turn it in until now.
Well, I was absent one day. Is that when y'all turned it in?
yes,
And it wasn't on Google Classroom either, so.
yes. But you watched the class recording to know to turn it in,
I looked at the slideshow.
and it said to turn it in,
Mm-hmm.
but then you didn't turn it in until now.
Is that not how it works? Am I supposed to turn it in yesterday?
No, I'm just saying you should have given it to me when you came in, though.
Sorry.
You shouldn't be using Gradebook as a way to figure out what to turn in. That's all I'm saying. Also, I honestly don't remember, but this test is either 40 or 50 points. It's one or the other. So that will be only your second major grade in Gradebook. The first being the limits quiz.
And remember, the limits quiz was only 20 points. Not that limits are not important,
It's just that your success on limits doesn't carry on the rest of the semester like this one does. So this test is more points because you need to, it's more important that you're up to speed for this unit. So, and then I promise half of the next unit, something called related rates, has a lot more interesting real world type of questions. We're still just in the learn how to do it phase. So. Anybody got a guess what you think the answer might be? It is 6. How'd you come up with that?
The number on the left raised to the number on the top divided by the number on the right.
Number on the left, raised to the power on the top, then divided by the number on the right. So 6 squared is 36, divided by 4 is 9. 4 to the third would be 64, divided by 32 is 2. 12 squared is 144. 144 divided by 24 is 6. Is that right? Yeah, that sounds good. I don't know how in the world you saw that. It would take me much longer than that.
I'm not gonna be here on Tuesday that we're taking the test.
Okay, so Wednesday during advisory.
Okay.
Have you seen this puzzle before, or you just got lucky? You tried the right thing. Yeah, I did post on Google Classroom if you want to see a little better explanation than that. But the answer was 6.